learn, grow, and succeed. Today is lecture 3 for class 12 physics. So let's get started and look at the topics for today. The first topic is capacitance of a spherical capacitor, and the second topic for today is grouping of capacitors. So first topic is capacitance of spherical capacitor. First of all, we will learn what is a spherical capacitor. In the last topic, we did capacitance of a parallel plate capacitor. A parallel plate capacitor has two metal plates with one given a charge plus Q and the other one earth. Okay. In spherical capacitor, we have two concentric spheres. Here, let us take two concentric spheres A and B. Okay. The sphere A is given a charge plus Q. Due to induction, equal and opposite charges appear on inner and outer face of the sphere B. The minus Q charge appears on the inner surface and plus Q charge appears on the outer face of the sphere B. Now the sphere B is earthed, so all the positive charge plus Q charge on sphere B flows to the earth. So the we have sphere A with plus Q charge and sphere B with minus Q charge, and hence an electric field exists between the spheres. Let O is the center, the radius of sphere A is small a, and the radius of sphere B is small b. Take a point P between the spheres which is at a distance r. Okay, now let's write a spherical capacitor consists of two concentric hollow conducting spheres. Hollow conducting spheres A and B. Radius of A is small a and radius of B is small b. If plus Q charge is given to sphere A due to induction, minus Q charge appears on the inner face of sphere B and plus Q charge on its outer surface. Since sphere B is Earth, hence plus Q charge on it flows to the Earth. So we have two spheres A and B with charges plus Q and minus Q respectively. Okay. Now, due to plus Q charge on A and minus Q charge on B, an electric field exists. An electric field exists between these two spheres. Okay, and a potential difference also exists between these spheres. Mm, At at point P, which is at a distance r from O, at point P, which is at a distance r from O, electric field electric field due to sphere A is equal to Q upon 4 pi epsilon naught r square, and due to sphere B is 0. Why 0? Because we know that the charge inside the conductor is always 0. Charge always resides on the outer surface, so charge inside the conductor is 0, and hence electric field inside the conductor is 0. Due to this electric field at point P, let us calculate the potential difference. Thus, potential difference between these spheres A and B is V is equal to VA minus VB, and we know that it is equal to integral A to B E dr. Okay, so we just calculated E is equal to Q upon 4 pi epsilon naught r square into dr. Here Q upon 4 pi epsilon naught is constant, so we take it outside the integration, and inside the integration we have dr upon r square, or Q upon 4 pi epsilon naught integral A to B r minus 2 dr. We know that integral x and dx is equal to x raised power n plus 1 upon n plus 1, and hence we have Q upon 4 pi epsilon naught r raised power minus 2 plus 1 upon minus 2 plus 1 integral A to B. So q upon 4 pi epsilon naught into r raised power minus 1 upon minus 1 a to b. Q upon 4 pi epsilon naught, sorry, minus q upon 4 pi epsilon naught into r raised power minus 1 को हम 1 upon r लिखेंगे, and integral limits are from a to b is equal to minus q upon 4 pi epsilon naught into upper limit minus lower limit. और अगर हम माइनस को अंदर ले जाएं, so we are left with q upon 4 pi epsilon naught into 1 upon a minus 1 upon b is equal to q upon 4 pi epsilon naught a b b minus a b का LCM a b, and from the summation from the sum of fractions we have b 1 upon a minus 1 upon b equal to b minus a upon a into b. So this is the value of potential difference V. We know that capacitance C is equal to charge upon V. Therefore, capacitance will be equal to Q upon 4 pi epsilon naught into B minus A into upon A into B. Q से Q कट जाएगा, so 4 pi epsilon naught into AB upon B minus A. This is the required expression for capacitance of a spherical capacitor. एक बार फिर से देखेंगे. We know that a spherical capacitor is a consists of two concentric hollow conducting spheres A and B. One is given one sphere A is given charge plus Q, and the other one, the sphere B, is earth. Due to plus Q charge on A, induced charges appear on sphere B, minus Q on the inner face and plus Q on the outer surface. Since sphere B is earth, hence the charge on the outer surface plus Q flows to earth. So we have only minus Q charge on B and plus Q charge on A. Due to these two charges on A and B, a potential difference exists between these two charges, which we calculated. V is equal to VA minus VB equal to integral A to B EdR. Okay, and the final value for the potential is this Q upon 4 pi epsilon naught into B minus A upon AB. So the capacitance which is given by Q upon B is equal to 4 pi epsilon naught AB upon B minus A. Okay, so now let's look into the next topic, which is grouping of capacitors. Grouping of capacitors. Capacitors can be connected in many different ways, but we will discuss only two ways here. One is capacitors in series and the other is capacitors in parallel. So first one is capacitors in series or series grouping of capacitors. Let's look into the diagram. Here we have three capacitors C1, C2 and C3. A1 B1 प्लेट्स हैं C1 कैपेसिटर की, A2 एंड B2 प्लेट्स हैं कैपेसिटर C2 की, एंड A3 एंड B3 प्लेट्स हैं कैपेसिटर C3 की. देखिए सीरीज कॉम्बिनेशन में एक कैपेसिटर का एंड दूसरे कैपेसिटर के फर्स्ट प्लेट के साथ कनेक्टेड है, दूसरे कैपेसिटर की दूसरी प्लेट नेक्स्ट कैपेसिटर की पहली प्लेट के साथ कनेक्टेड है. तो जब कैपेसिटर्स को हम एंड टू एंड इस तरीके से कनेक्ट करते हैं तो उसको हम बोलते हैं कैपेसिटर्स कनेक्टेड इन सीरीज. ओके, सो सबसे पहले डेफिनेशन लिखेंगे. कैपेसिटर्स इन series. Capacitors are capacitors are said to be connected or joined in series when they are connected end to end. Means second plate of one capacitor is connected to first plate of the next capacitor and so on. पहले कैपेसिटर की दूसरी प्लेट B1 ये कनेक्टेड है दूसरे कैपेसिटर की पहली प्लेट A2 के साथ, और दूसरे कैपेसिटर की दूसरी प्लेट B2 कनेक्टेड है नेक्स्ट कैपेसिटर C3 की पहली प्लेट A3 के साथ. Okay, so this type of grouping of capacitors is known as capacitors connected in series. So now let's calculate the effective capacitance of this grouping. We have three capacitors connected to a common battery. When battery supplies plus Q charge, appears on the first plate A1. Due to induction, minus Q charge appears on the plate B1 and plus Q charge on its further face. This plus Q charge flows to the first plate A2 of the second capacitor, and due to induction minus Q charge appears on the inner face of plate B2 and plus Q charge appears on the further face of B2. This positive charge again flows to third capacitor plus Q appears on the plate A3 due to induction, minus Q on its inner face and plus Q on its outer face, and the plus Q charge flows to the earth. Two terminals here are A and B. So we just learnt that each capacitor receives same charge Q, same charge plus Q plus Q and plus Q. Okay, so now we, mm, we know that Q is directly proportional to V and Q is equal to CV. Also, each capacitor is at different distances from the battery. Hence, the potential will be different because V is equal to EDR, depends on the distance. So, capacitance on voltage or potential at capacitor V1, capacitor C1 is V1, at capacitor C2 is V2, and at capacitor C3 is V3. V1 is equal to Q upon C1, V2 is equal to Q upon C2, and V3 is equal to Q upon C3. V is equal to, because V is equal to Q upon C. Here Q is equal to small q. Therefore, V, which is equal to Q upon C, will be equal to will be equal to uh, V1 plus V2 plus V3. V is equal to Q upon C is equal to V1 plus V2 plus V3 is equal to Q upon C1 plus Q upon C2 plus Q upon C3. Q upon C is equal to Q1 upon C1 plus Q upon C2 plus Q upon C3. If we take Q outside, so Q into 1 upon C is equal to, also Q is common here, it can be taken out, and we have 1 upon C1 plus 1 upon C2 plus 1 upon C3. Q on both sides cancels out each other. So 1 upon C is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. This is the required expression for the equivalent or effective capacitance in grouping of in series grouping of capacitors. What is this? Reciprocal of effective capacitance, and it is equal to the sum of reciprocal capacitances of individual capacitors. Hence, effective capacitance in series combination, uh, hence reciprocal, sorry, hence reciprocal of effective capacitance in series combination is equal to the sum of reciprocal of each resistance taken individually. अगर हर एक रेजिस्टेंस की सॉरी हर एक कैपेसिटर की कैपेसिटेंस के रेसिप्रोकल्स को हम इंडिविजुअली उनको सम कर दें तो दैट विल बी इक्वल टू द reciprocal of effective capacitance of the series combination. Next is capacitors in parallel. Capacitors in parallel. In the diagram, we can see that here one plate of each capacitor, one plate of each capacitor. This A1 plate, A2 plate of C2 and A3 plate of C3. All these are connected to a same point, and B1, B2 and B3 plates are connected to other end. This type of combination where first plate of each capacitor is connected to one end and second plate of each capacitor is connected to another end. This type of combination, this type of grouping is known as capacitors connected in parallel. So let's write the definition. Capacitors are said to be joined in parallel when positive plates when positive plates of all the capacitors are are connected to a single point and all the negative plates are connected to another point and a certain and a certain potential difference is applied across these points. So if potential V is applied, the same the potential across the plates will be same. Why? Because each point is each plate is connected to a similar point, same point, and hence the difference for each capacitor from the battery will be same, and hence V will be same across the combination. Potential will be same. V, V and V. But the charge will not be same here. If the battery supplies plus Q charge, it gets distributed at this point. Let charge Q1 flows to A, Q2 flows to B, and Q3 flows to B. Q1, Q2 and Q3. But at the end, the same charge will be on both sides of the combination. Plus Q charge here and plus Q charge which flows to the earth. Now here, now let's calculate the effective capacitance of a parallel combination. We know that Q is directly proportional to V and Q is equal to CV. Since V is constant in parallel combination, but Q is not constant. So Q1 will be equal to C1V, Q2 equal to C2V, and Q3 is equal to C3V. Since Q is equal to CV, we can replace Q by CV. Or total charge Q is equal to Q1 plus Q2 plus Q3. Q is equal to CV and Q1 is equal to C1V plus Q2 equal to C2V plus Q3 is equal to C3V. CV is equal to, here V is common, we can take it outside, V into C1 plus C2 plus C3. V on both sides cancels out each other. Therefore, C is equal to C1 plus C2 plus C3. This is the required expression for the effective capacitance in parallel combination. So, the effective capacitance of parallel combination is equal to the sum of individual capacitors, capacitance of individual capacitors. Okay, effective capacitance in parallel combination C is equal to the sum of capacitances of individual capacitors C1 plus C2 plus C3. So these were the topics for today. अगर आपको वीडियोस पसंद आए हो तो लाइक कीजिएगा, शेयर कीजिएगा और चैनल को सब्सक्राइब कीजिएगा। थैंक यू बच्चों।